Okay, so topic 4, simplifying expressions. We're going to go through the topics of PEMDAS. We just went through that, so I'm going to just skip over that section. Combining like terms in the distributive property, multiplying binomials, or it's known as the FOIL method, GCF, greatest common factor, and simplifying expressions. So in these cases, we are going to have our variables in the problems, and we might not be able to solve them, but just simplify them as much as possible. So we're going to skip over that PEMDAS chart. We just did that. And we're going to go into the concept of combining like terms. So on combining like terms in distributive property, we just have a lot of vocabulary here. If you already know what these are, you don't have to write it if you already have the notes printed out, such forth. So the first one is variable. So a variable is a letter used to represent a number. The most common variables you're going to see are x and y. But that is not limited to just x and y. They can have any variable, any letter in there. A term is a part of an expression separated by an operation. So in the expression 5x plus 6, we have two terms, 5x and 6. So it's the numbers separated by an operation. Coefficient. This number is attached to a variable. In the expression 5x, 5 is the coefficient. And I wrote important, if you don't see a number attached to a variable, we assume that number is what? So if you just see x, and I say, what is the coefficient of x, what would it be?
1.
Good, 1. Constant term is the term that does not contain a variable. So in the expression 5x plus 6, the constant would be 6. So the one that does not have a variable. Like terms are terms that have the same variable parts. So 5x and x would both be like terms, meaning we could combine them into one. And then lastly, the distributive property. Here's the formula for it. Is a times parentheses b plus c tells us that we just take the a and multiply it in. So we get a times b plus a times c. Okay. Again, these are all terms, vocabulary that you should have seen before. So I'm just going through it fairly quickly. Okay, on the first set of examples, it says determine if the following are like terms or not, and then tell me why. So we're just saying if they're like terms or not, yes or no. So on number 1, like terms? Yes. Why? Good, they both have x's. What about number 2, yes or no?
No.
Good, no. Why? Good, so they both technically have the same variable y, but one is y to the power of 1, because we don't see that there. And the other one is y squared. So since they have different exponents, they're considered different variables. So this is a no. What about number 3?
No.
Why? Good, one is xy and one is just x. So that's why they are not like terms. Okay, what about 4?
Yes.
Good, yes, why?
Same variable.
Good, so it's the same variable and the same exponent, so m squared. And then lastly on 5, yes or no? No, why? Good, so the 2 doesn't even have a variable attached to it, so this is a variable with a coefficient and then just a constant term. Okay. On the next set of examples, it wants us to practice using the distributive property. So remember, when we see distributive property, that means we're using what operation? Multiplication. So this is going to be 6 times x, 6 times 1. So 6 times x, do I write it like this? No, when we have a number attached to a variable, we don't write that multiplication sign, so this is wrong. We just write 6x, okay? Plus 6 times 1, which is 6. Can we combine these terms? No, so this is our answer. Okay, on the next one, am I distributing the 2 or am I distributing the negative 2? Negative 2. So I have negative 2 times 2x, which gives me negative 4x, and negative 2 times 3, which gives me negative 6. Are these like terms? No, so this is my answer. What about number 8? Number 8, we don't have a number to distribute. We don't see a number. We assume that number is 1. So I would write a 1 here. And am I distributing a 1 or a negative 1? Negative 1. So negative 1 times y, how would I write that? Negative y, and negative 1 times negative 4x just turns this into a positive 4x. Are they like terms? No, so that's my answer. What am I distributing on 9? Good, a negative 1x. Oops. Okay. When I multiply an x and an x together, what does that give me? X squared, because there's 2 x's. So I have negative x times x, which is negative x squared. Negative x times 3x, negative 3x squared. Negative x times 2, negative 2x. Do I have any like terms? What are my like terms? Good, and if I combine them, that gives me what?
Negative 4x squared.
Good, negative 4x squared minus 2x. Any more like terms? No, so this is my answer. Okay, what am I distributing on 10?
6xy.
Good, 6xy. So again, if I'm multiplying two variables that are the same, it's going to become squared. What if there is not a variable in there? So for example, when we multiply this first part, there's only an x to be multiplied by another x. What is going to happen to that y? Just stays the same. So this is 6x squared y. Okay, because we have nothing to multiply that y by in the first part. Okay. And then in the next part, we have plus 24xy squared. Are these like terms? No. So this is our answer. Okay, so we talked about like terms. We talked about the distributive property. Now we're going to do examples of combining like terms. So that means we may have the distributive property to do in there and then combine like terms at the end. So on number 11, what would be our first step? Good, the parentheses. Since we can't simplify those parentheses though because of that variable, what are we going to be doing with that 4? Distribute. So we're going to distribute the 4. That's our first step. So 5x plus 4x minus 8. Do we have like terms? Okay, what are they?
5x and 4x.
Perfect. So this is 9x minus 8. Any more like terms?
No.
So this is my answer. Okay, and these ones you're not going to get a number answer. You're going to just get an answer that looks like an expression. So it's going to have a variable in it. Okay, number 12, what are we doing first? Distribute, good. Anytime you see anything outside of the parentheses, we are going to distribute. So that leaves me with 14xy plus 2xy plus x squared plus 5x to what power? Third. Because now we are having x being multiplied x squared. There is one additional x, so x squared turns into x cubed. Do I have like terms? What are my like terms?
2.
Good, just right here. So then this becomes 16xy plus x squared plus 5x cubed. Any more like terms? No, so that's my answer. Okay, do I have anything to distribute in number 13? No, there's no parentheses. That means I have nothing to distribute. So I'm going to start looking at like terms. Do I have any like terms? Okay, I have several. Well, it could be one. Good, so my m squares. Anything else?
7 and 1.
Good, my y's. So negative y and 7y gives me 6y. 4m squared and negative 20m squared gives me negative 16m squared. And then I'm just going to bring down that plus 7m to the fourth because it had nothing to combine with. Okay, and that would be my answer. Any questions so far? What would I do for 14 first?
Distribute.
Good, distribute, because I have those parentheses. So I have 12xy minus 72x to what power? Squared. I'm going to bring down my 4xy, bring down my minus 2. Do I have any like terms?
Yes.
Good, my xy's. Oops, right here.
16.
Good, so 16xy minus 72x squared minus 2 is my answer. Okay, what about on 15? Do I need to distribute anything? No, I don't need to distribute anything, so what am I going to start doing? Combining like terms. What's one like term on here I can combine?
Your y squared.
Y squared.
B's.
8 y squared.
B's, good. What else?
XY.
XY. Okay. So I'm going to start left to right. So I'm looking at my y squared. So y squared plus 7y squared is 8y squared. Okay, now I'm looking at my b's. 12b minus 4b is 8b, but then I have an additional 1b over here,
7.
so 9b, because they're all positive. So 9b, because 12b minus 8b is, yep. Okay, then I'm looking at my xy, so I have 1xy and a negative 23xy, so I have a negative 22xy. And I'm going to bring down that 7by because it didn't have anything to combine with. So that's my answer. Okay. And that concludes that topic of combining like terms. Okay. So we have one last concept on, well, no, we have a couple more. We have what, 9 minutes? Okay, we'll go through probably just this last concept. And then we'll finish it out on Monday. Okay, this next concept here is the FOIL method, or in other words, multiplying binomials. Was there a question? Okay. When someone says binomial, they're talking about an expression inside of a parentheses. So this is a binomial because we're having two parentheses being multiplied together. What do you think 3 parentheses multiplied together would be?
Polynomial.
A trinomial. So we have binomial, trinomial. We will be doing those when we talk about quadratics. Okay, so it says using the FOIL method, multiply the following binomials. So the FOIL method up here, the formula is if we have a plus b in parentheses times c plus d in parentheses, that's the same as saying a times c. So let me write this out. A times c Okay, and then A times D, and then B times C, and B times D. Okay. So pretty much what we're doing is that we are distributing the first term, A, and then we're distributing the second term, B. Okay. So let's go ahead and do that on 16. So on 16, I have 3x times x. 3x times x is 3x squared. Okay. Now I'm going to take that 3x and multiply it by the second term, 3. So 3x times 3 is 9x. Okay, so that was me distributing the first term, 3x. Now I'm going to distribute the second term, 2. So 2 times x is 2x. And 2 times 3 is 6. Any questions on how I foiled that first problem? Okay. Once I have everything foiled, what do you think my next step is? Combine like terms. What are my like terms? 9x and 2x. So I have 3x squared plus 11x plus 6. Do I have any more like terms to combine? Nope, so this is my answer. So when we multiply binomials using the FOIL method, we're going to get a quadratic equation. So multiplying binomials gives you a quadratic equation. So we are learning all these little skills, so when we get to the topic of quadratics, you'll be able to simplify them no problem.
What did you say again? Multiplying binomials gives what?
Quadratics, so quadratic equations. Okay, number 17, we're first going to distribute the x, and then we're going to distribute that -2. Okay, so distributing the x first, we have x times x, which is x squared, x times -3 because of that minus in front, which gives us -3x. Okay, so we distribute the x. Now we're distributing the second term, that -2. -2 times x is -2x. -2 times -3 is +6. Okay, and what's my last step? Combine like terms. So when we're multiplying binomials and we get that quadratic equation, your like terms are always going to be the middle pair. Okay, your like terms when we are multiplying binomials is always that middle pair. So we have x squared minus 5x plus 6. Okay, I'll go ahead and we'll do 2 more and then we'll finish the rest on Monday. Okay, so what are we going to distribute first on 18? 2x. And then what are we distributing next? The 3. So always the first term, then the second term. So 2x times 2x is 4x squared. 2x times -3 is -6x. 3 times 2x is +6x. And 3 times -3 is -9. What happens to my like terms in the middle? They cancel out. So am I going to have a middle term? No. So my answer is 4x squared minus 9. Because these cancel. -6 and +6 gives me 0. Okay. And last one for today, number 19. We have 3x plus 3 and x plus 4. What am I distributing first? 3x, good. And then what am I distributing? 3. So I have 3x times x, which is 3x squared. 3x times 4, 12x. 3 times x, 3x, and 3 times 4, 12. When you combine our middle terms, what is that middle term? 15x. So I have 3x squared plus 15x plus 12. And that is our answer.